Welcome to Exponential Growth and Decay. You may remember this or parts of this topic from year 11. We did cover some of these rules, in particular how to integrate or how to differentiate. So we're going to look at these in regards to growth and decay formulas and use some real life examples. So we're going to work with the properties of exponentials, and that is that the derivative of an exponential gives us the exponential itself. And it's going to help when we're dealing with these to represent Q as the quantity and T as to represent time. And therefore, Q to T is the changing quantity with respect to time, because we're going to be looking at rates. And remember, rate is the derivative where we look at the quantity with respect to time. So we have Q equals e to the t, then Q to t equals e to the t itself, because if you differentiate an exponential, you get itself, meaning Q to t equals the quantity itself. If we had some constant, so e to the kt, then when we differentiate, we get ke to the kt, because remember, when you differentiate an exponential, you differentiate the power, the kt, it comes out the front, so the k, and you rewrite the exponential. So that means that Q to t would equal to k lots of the original quantity, meaning that our rate of change is proportional to the quantity itself. Exponential decay is now we're looking at negative kt, because our exponential is coming in a downward form. And so when you differentiate that, you get minus ke to the kt, and that means Q to t is minus k lots of the quantity. So still in a proportion. So let's have a look at some examples. So we can use a variety of pronumerals. So we just use Q, but we could represent M for mass and M0, which is the mass at time 0. So we could have M equals M0 e to the kt, and when we differentiate, we'd get k lots of M. And we can have P is the population of a town, so P0 is the population at time 0. So these may come up, just in case they were to. So here's an example. Estimated population from the Goulburn website is in 2024 will be approximately 34,000, and estimated that it'll grow to 38,000 by 2036. It's growing according to exponential growth, and the population is the after 2024. So 2024 represents the initial or t equals 0. So step 1, we're going to show that P equals P0 e to the kt satisfies the differential equation. That question comes up more often than not in exams. So I'm just making sure that we put that in there. We're going to find the value of P0 and K, estimate the population in 2050 if it continues to grow with this exponential. When will the population get to 50,000? And we're going to look at the rate at which the population is increasing. So the first one. So showing that it satisfies the equation, so we take the P equals P0 e to the kt and we differentiate. So the P to T is equal to, so the rule that we spoke about before with an exponential, you differentiate the power, which is K, put it out the front, and you leave the exponential as it is. So you get K lots of P0 e to the kt, which is K lots of what the P value was in the first place. So therefore it satisfies the differential equation. Second part, finding P0 and K. So since we're taking 2024 as the initial year, so time is 0, and the population is 34,000 at that time, we're going to prove that P0 equals 34,000. Now you can make an assumption in the exam, but we'll prove that it is. So our formula was P equals P0 e to the kt. So our 34,000 is our population, and our time is 0. You get e to the 0, which is 1, So you get P naught lots of 1, which is P naught. That shows or proves that P naught equals the 34,000. Our other part of the question said that 12 years later, the population is now 38,000. So we get 38,000 equals 34,000 e to the k12. So divide by the 34,000, so you get 38 over 34. I mean, we could simplify that to 19 over 17, but when you're using logs, it doesn't matter. So e to the 12k. Remember, if I have e to the 12k, e is the base to the 12k. So if I want to leave the 12k by itself, I end up with log of base e on the other side, or ln, of 38 over 34. Put that on my calculator and divide by the 12, and I get k equals 0.00927. So now that's my k value. For the rest of these questions, my k value is 0.00927. So what's the estimated population in 2050? Well, that's 26 years later. So I just substituted into the formula. So 34,000 e to the 0.00927 lots of 26. Put that on your calculator and you get 43,266. When will the population reach 50,000? So that's the P. So put that where the 50,000 is. Divide by the 34,000 and you get 50 over 34. Same as before. If I want to leave the 0.00927 to the t as my right-hand side, and I've got a base e, on the other side I'm going to make it log base e of 50 over 34, or ln. Use my calculator, and I get ln 50 over 34 divided by 0.00927. So about 42 years it'll take to reach, after 2024 that is, to reach 50,000. So about 2066 is when we'll get to 50,000. And our last question, find the rate. So when we're finding the rate, to P to T equals to KP. So to P to T equals to 0.00927 lots of P. And because we know our population is 38,000 in 2036, we can substitute that in. So the population in that particular year, 2036, is growing at about 352.26, or around 352 people that year. For our second example, let's look at a depreciation question. So we know that a car is depreciating in the form of P to T equals minus KP. This means that we know that it's differentiating in the form of an exponential, and exponential decay in this case. The price halves every 8 years. How long will it take to be worth 10% of its original price? So let's start with the first part. It decays, or the price halves every 8 years. So our formula is always P equals P naught e to the minus K this time, because we've got a negative growth. So it's the decay. And from our original population, our population in 8 years is half. So half of P naught, the original, equals to P naught e to the minus K times 8. Dividing both sides by P naught, you get a half equals e to the minus K8. Taking the log base e of both sides and putting that on your calculator, dividing by the minus 8, you get K as a value of minus 0.866. So now substituting that in, and we want it to be 10%, so 1/10 of our original population. P naught equals P naught e to the minus 0.866t. 1/10, dividing both sides by the P naught, taking the log of both sides and dividing by minus 0.0866, you get the price will be 10% in 27 years. Thank you.